Hey yo, it's me, Factor and Frank, back talking to you about graphing quadratic functions in vertex form. Now here's a question. Why should you always invite a construction worker to your party? Because they know how to raise the roof!
First thing we're going to do is review what a quadratic function is. So that's an equation of degree 2 written in the form y equals ax squared plus bx plus c. And here you can see we have some examples of quadratic functions. Now today what we're going to do is actually take a quadratic function like this and rewrite it a little bit so that it's no longer in standard form, which is what this is. It'll be in vertex form. Now, a parabola is the graph of a quadratic function written in the form y equals ax squared plus bx plus c. Again, anytime you have a degree 2 polynomial, that's a quadratic function. The graph of that is going to be a parabola. The vertex is the highest or lowest point on a parabola. So if your graph opens upward, your quadratic function has a positive a value. That means that your vertex is going to be at the bottom of that parabola. It's going to be the lowest point of the parabola. Here, your graph has a negative a value, which means your parabola opens downward, which means your vertex is going to be the highest point on your parabola. Now, the axis of symmetry is just a line through a shape so that each side is a mirror image. In quadratic functions of the form y equals ax squared plus bx plus c, we remember that the axis of symmetry is found with the formula x is equal to negative b over 2a. What we used to do is we used to have to look at our formula and then plug in your b value from the function and your a value from the function in order to get your axis of symmetry. Today, we're going to be in vertex form, not standard form like this. We're going to be in vertex form, and it's going to be a lot easier to find your axis of symmetry, aka your x value of your vertex. A parent function. We went over this a while ago, but I want to make sure you remember what this is. It's the simplest function of a family of functions that preserves the definition or shape of the entire family. So it's like the most basic form of a particular function. So in a linear function, the most basic form is y equals x. In a quadratic function, like we're dealing with today, the most basic form of a quadratic function is y equals x squared. There's no b, there's no c, and your a value is 1. It's the most basic it can get. And these are some other parent functions for those family of functions. In this case, our parent function of y equals x squared, this is what we're going to be dealing with today. You want to figure out with your new function that you're given, how does it differ from the parent function, or what does it do to the parent function in order to get that new function? So again, we'll talk about that today. Now, we're going to review standard form of a quadratic function. We talked about this a little bit so far. Remember, your a value, if it's positive, you have a parabola that opens upward. If it's negative, it causes a reflection over the x-axis, which means your parabola opens downward. If your a value is greater than 1 or less than negative 1, so 2 or negative 2, 100 or negative 100, your parabola is going to be stretched. It's going to be thinner than it usually is. Whereas if your a value is between negative 1 and 1, then you know that your parabola is going to be compressed. It's going to be flatter than it usually is. And note that a cannot equal 0 in a quadratic function. Otherwise, it's no longer a quadratic function. Okay, for our b, if we plug that into x equals negative b over 2a, that gives you the x value of your vertex and the axis of symmetry. If you want to get the y value of the vertex, all you had to do was take that negative b over 2a, plug it back in the function for x here and here, and then solve for y. And that'll give you your y value of your vertex. The c value determines the y-intercept of your particular function. Now, vertex form, this is what we're going to be dealing with today. Vertex form of a quadratic function. The a does the exact same thing. If your a value is positive, your parabola opens up. If your a value is negative, it causes a reflection over the x-axis, so your parabola opens downward. If your a value is greater than 1 or less than negative 1, then your parabola is going to be stretched. It's going to be thinner. If your a value is between negative 1 and 1, not equal to 0, then your parabola is going to be compressed. It's going to be a flatter parabola than you usually see. Now, this time we have an h and a k. So h determines the x value of your vertex. K determines the y value of your vertex. So you already have your vertex. That's why it's in vertex form, h comma k. So h, again, is the x value of vertex. It's also the axis of symmetry. If you write x equals h, that's the axis of symmetry. And it's the horizontal translation of your parent function. It tells you how many units to move left or right from your parent function. Your k value, again, is the y value of the vertex, and it's the vertical translation of the parent function. So it tells you how many units up or down to move from the parent function. Please note that in front of a k, you have a plus sign, but in front of your h, there is a minus sign. So in order to figure out your k value, you just look at it and you can tell whether it's positive or negative. In order to figure out your h value, you have to look at this and just take the opposite of whatever you see. So if it's -1, your h value would be +1. If it's +3, your h value is going to be -3. Now let's talk about graphing a quadratic function. So this time we're going to graph out of vertex form. So it's exactly the same steps, except it's way easier this time because in the first step, you're going to find the axis of symmetry or x value of vertex using x equals h. You don't even have to plug in -b/2a. It's just look at what your h is, take that, plug it in here, and that is your axis of symmetry. Then you're going to make a t-table with your vertex in the middle. Your vertex, if you recall, is h, k. H is the x value of vertex, k is the y value of your vertex. You're then going to choose two x values above and below the x value of your vertex. So pick two x's above, two x's below, just like we did. We're going to take all of those x's, plug them back into the original function up here for x, simplify, and get the y values that go with them. Then we're going to plot those points. So let's do it.
Why didn't the construction worker get hurt when a can from a building fell and hit him on the head? Because he was wearing a hard hat and it was a soft drink. Boom! Example time.
Okay, example 1. We're going to graph this function in vertex form, then we're going to state the transformations to the parent function at the end. Okay, so step 1, we're going to find the axis of symmetry or x value of vertex using x equals h. So in this case, we need to figure out what's our a, what's our h, and what's our k. So our a value is this invisible number out front. So since there isn't anything, it's just a 1. Can't be 0, otherwise it would make everything 0. Here, we need to then figure out our h value. So remember, inside the parentheses, our h value is going to be the opposite of what you see. So if this is -1, your h value is going to be +1. And last but not least, your k value is exactly what you see. So whatever's added or subtracted at the end, that's your k value. So in this case, that would be -1. Our axis of symmetry is x equals h, which in this case is 1. So we're going to have a axis of symmetry at x equals 1. So we put a vertical line to create our axis of symmetry at x is equal to 1 because that's the equation of a vertical line. Remember, the axis of symmetry is also a good way to check your work because the parabola should be the same on both sides of the axis of symmetry. Now let's move on to our next step, which is to make a t-table with the vertex in the middle. So the question is, what is the vertex? Remember, the vertex is just h, k. So 1, -1. That goes in the middle. We're then going to pick two x values above 1 and two x values below 1. We then plug those x values back into this particular function to get the y values that go with them. Don't forget, we have to use the order of operations when we're simplifying. So let's plug in 3. 3, we plug that in for x. We do parentheses first. 3 minus 1 is 2. Then we do exponents. 2 squared is 4. Then we multiply or divide. Nope. Then we add or subtract. So 4 minus 1 is 3. Perfect. Plug in 2. 2 minus 1 is 1. 1 squared is 1. Minus 1 is 0. We then plug in 0. 0 minus 1 is -1. -1 squared is +1. Minus 1 is 0. Plug in -1. -1 minus 1 is -2. -2 squared is +4. Minus 1 is 3. Now all we have to do is plot these points and we're done. 3, 3. We go over 3 on our x-axis, up 3 on our y-axis, put a point. 2, 0 over 2 on our x-axis, up or down 0, put a point. 1, -1, that's our vertex. We go over 1 on the x-axis, down -1 on the y-axis, put a point. 0, 0, that's the origin right here. And then -1, 3 over -1 on the x-axis, up 3 on the y-axis, put a point. Draw a parabola going through those. Sweet, we graphed it, and you can see our axis of symmetry cuts our parabola in half. We did it right. Now let's state our transformations to the parent function. So remember, transformations to the parent function. The parent function is y equals x squared. So basically it's asking what did our a do, what did our h do, and what did our k do. So our a is 1, so it didn't do anything, right? It didn't stretch it, didn't compress it, it didn't reflect it over the x-axis. So our a didn't do anything. What about our h? Well, our h is 1, which means that it moved the parent function to the right 1 unit. And you see, instead of having our vertex at the origin, we are moved to the right 1. So we have a horizontal translation, right 1 unit. That's how you say that. Then your k value is -1. That controls whether the graph moves up or down. Since your k is -1, that means that your graph, your parent function, shifted down 1. So we shifted to the right 1 unit, and then we had a vertical translation down 1 unit. So right 1, down 1. Yeah, that's how we shifted our parent function.
How did the construction worker feel after eating a bunch of tools? It was gut-wrenching. Hell, you tried.
Okay, doing the same thing. So step 1, we need to find the axis symmetry using x equals h. So let's figure out what's our a, what's our h, and what's our k. So our a value is 1 because there's nothing out here. Our h value is going to be opposite of what you see in here, so it's going to be -3. And our k value is going to be what's added or subtracted at the end. That's -9. Sweet. So our axis symmetry is just x equals h, that's x equals -3. So at x equals -3, we're going to create a vertical line. That's our axis symmetry. It's a good way to check our work to make sure our parabola is the same on both sides of that line. We are then going to make a t-table. Put our vertex in the middle. So what's our vertex? H, comma, k. -3, comma, -9. That goes right in the middle. We then choose two x values above -3 and two x values below -3. We then plug those x values into the original function to get the y values that go with them. So if I plug in -1 for x, remember we do the parentheses first, then we square it, then we subtract 9. So plug in -1. -1 plus 3 is going to be 2. 2 squared is 4, and then 4 minus 9 is -5. Plug in -2. -2 plus 3 is 1. 1 squared is 1. Minus 9 is -8. Plug in -4. -4 plus 3 is -1. -1 squared is +1. Minus 9 is -8. And then -5, I plug that in. -5 plus 3 is -2. -2 squared is 4. And then 4 minus 9 is -5. Now let's plot these points. So -1, comma, -5. I go over -1 on the x-axis, down -5 on the y-axis, put a point. -2, comma, -8. I go over -2 on the x-axis, down -8 on the y-axis, put a point. -3, comma, -9, our vertex. We go over -3 on the x-axis, down -9 on the y-axis, put a point. -4, comma, -8. We go over -4 on the x-axis, down -8 on the y-axis, put a point. And then -5, comma, -5. Over -5 on the x-axis, down -5 on the y-axis, put a point. Draw a parabola going through those. Looks like we graphed it correctly because our axis symmetry cuts it right down the middle. Sweet. Now let's figure out the transformations to the parent function. What did our a do, what did our h do, and what did our k do to y equals x squared? A, you multiply it by 1, that doesn't do anything. But our h is -3, which means it took y equals x squared, the graph of the parent function, and moved it to the left 3 units. So that's what we say. We say a horizontal translation left 3 units. Our k value is -9, meaning that it took the original graph of y equals x squared and moved it down 9 units. So a vertical translation down 9 units. And that's how you figure out what your transformations are. Example 2, doing the same thing. So step 1, we need to figure out the axis of symmetry, which is x equals h. So what's our a, what's our h, and what's our k? Our a value, it's no longer just 1. There's a little negative out here. So our a value is actually -1. Our h value is the opposite of what you see in these parentheses. So it's going to be +2. And our k value is exactly what you see out here. So it's going to be +3. We then go ahead and figure out what's our axis of symmetry. Well, it's x equals h. We figure out our h is 2. So x equals 2 is going to be our axis of symmetry. So we go over to x equals 2, draw a vertical line. That's going to be our axis of symmetry. It's going to cut our parabola in half. We then make a t-table with our vertex in the middle. What's our vertex? H, comma, k. 2, comma, 3. We then pick two x values above 2, two x values below 2, and we're going to plug them into the function to get the y values that go with them. So remember, do what's in the parentheses first, then you square it, then we're going to tack on this negative, and then we're going to add 3. So let's start with 4. If I plug in 4 for x, 4 minus 2 is 2, 2 squared is 4, then you tack on the negative, becomes -4, plus 3 is -1. Plug in 3 for x. 3 minus 2 is 1. 1 squared is 1. Tack on the negative, becomes -1, plus 3 is 2. Plug in 1. 1 minus 2 is -1. Square it, it becomes +1. Tack on the negative, becomes -1 again, plus 3 is going to be 2. We then plug in 0 for x. 0 minus 2 is -2. -2 squared is 4. Then tack on the negative, becomes -4, plus 3 is -1. Now let's plot these points. So 4, comma, -1, we go over 4 on the x-axis, down -1 on the y-axis, put a point. 3, comma, 2, we go over 3 on the x-axis, up 2 on the y-axis, put a point. 2, comma, 3, we go over 2 on the x-axis, up 3 on the y-axis, that's our vertex. 1, comma, 2, we go over 1 on the x-axis, up 2 on the y-axis, put a point. And then 0, comma, -1, over 0 on the x-axis, down -1 on the y-axis, put a point. Draw a parabola going through those. There we go. We are done. Now let's state our transformations to the parent function. So how did this change from y equals x squared? Well, it basically is just asking, what did our a do, what did our h do, and what did our k do? So our a is -1. Because our a is negative, that caused the parent function, which is normally y equals x squared, and opens like this, to flip over the x-axis or reflect over the x-axis. Now, since our h is 2, that caused the parabola or parent function to move to the right 2 units. So it would be a horizontal translation, right 2 units. Last but not least, our k value, 3. So that determines vertical translation. So how much up or down did it move? Well, since it's positive 3, the vertex shifted up 3 units, or the parent function shifted up 3 units. So it would be a vertical translation up 3 units. So if you took the parent function, flipped it over the x-axis or reflected over the x-axis, horizontally translated it right 2 units and up 3 units, that's how you get this new parabola. Those are the transformations that had to take place in order to create this new function.
What did one construction worker say to the other construction worker when he screamed at a tool? Relax! It's only a drill! Oh, you try.
Okay, so we're going to do the same thing here. Step 1, we want to find the axis symmetry or x value of vertex using x equals h. So what's our a, what's our h, and what's our k? So our a value is going to be this -2 that's out front. Our h value is going to be the opposite of what you see in here, so it's going to be +1. And our k value is going to be exactly what you see out here, so it's going to be +5. So if we're finding our axis symmetry, that's x equals h. That's, in this case, going to be x equals 1. So we go over to x equals 1, draw a vertical line, and that is going to be our axis symmetry. That's going to cut our parabola in half. It's a good way to check our work. Next, we are going to make a t-table with the vertex in the middle. So what is our vertex? Well, our vertex is h, k. So in this case, that would be 1, 5. We then go ahead and pick 2 x values above 1 and 2 x values below 1. We then plug those x values back into this original function and get the y values that go with it. Remember, order of operations. We're going to do the parentheses first. So when we plug something in, we'll do the parentheses, then we'll square it, then we'll multiply it by -2, and then we'll add the 5. So let's do that. If I plug in 3 for x, I do 3 minus 1, get 2. 2 squared gives me 4. 4 times -2 is -8, plus 5 is -3. Then I plug in 2. 2 minus 1 gives me 1. 1 squared is 1. Times -2 is -2, plus 5 is +3. Then I plug in 0. 0 minus 1 is -1. -1 squared is +1. Times -2 is -2, plus 5 gives me 3. And then -1, I plug that in for x. -1 minus 1 is -2. -2 squared is +4. Times -2 is going to be -8, plus 5 is -3. Now let's plot these points. So 3, -3, I go over 3 on the x-axis, down -3 on the y-axis, put a point. 2, 3, I go over 2 on the x-axis, up 3 on the y-axis, put a point. 1, 5, over 1 on the x-axis, up 5 on the y-axis, that is our vertex. 0, 3, I go over 0 on the x-axis, up 3 on the y-axis, put a point there. And then -1, -3, I go over -1 on the x-axis, down -3 on the y-axis, put a point. Draw a parabola going through those, and I have graphed my given function. Now let's state the transformation to the parent function. So what did our a do, what did our h do, and what did our k do? So first, our a value is negative. Because our a value is negative, that means that it caused a reflection over the x-axis. That's why it's opening downward. So the negative is taken care of now. What about the 2? What does the 2 do? Well, since it's greater than 1 or less than -1, we know it's going to stretch your parabola. So this is going to be a vertical stretch by a factor of 2. Why don't we say -2? Because the negative is the reflection. The stretch is then the number that comes after that negative. Here, we also have a horizontal translation right 1 unit. That's what our h equals 1 means. So we shifted our parent function to the right 1 unit. You can see the vertex moves to the right 1 unit. It also moves up 5 units, and that's because of our k value. So the k value causes a vertical translation up 5 units. Okay, example 3, doing the same thing. So first, we want to figure out what is our axis symmetry, or x value of the vertex, using x equals h. So we need to figure out what's our a, what's our h, and what's our k. So our a value is going to be this 3/2. Our h value, the opposite of what you see in this parenthesis, so it's going to be +1. And our k value is going to be exactly what you see on the end, so that's going to be 1/2. So our axis symmetry is x equals h, so in this case that would be x equals 1. So we go over to x equals 1, draw a vertical line, that's where our axis of symmetry is. We then go ahead and make a t-table, putting our vertex in the middle of that t-table. What's our vertex? That's h, k, so 1, 1/2. That goes in the middle of our t-table. We then are going to pick 2 x values above our given vertex and 2 x values below our given vertex. And we're going to plug those into the function up here to get the y values that go with them. So again, when we plug in stuff up here, do the parentheses first, then you square it, then you multiply it by 3/2, then you add the 1/2. So if I plug in 3 for x, 3 minus 1 gives me 2. 2 squared is 4. Then I multiply 4 times 3 over 2. 4 times 3 over 2, 4 is the same as 4 over 1. So I multiply the 4 times the 3 and the 1 times the 2. So I get 12 over 2. Then I add 12 over 2 to 1 over 2, and I get 13 over 2, or 6.5. If I plug in 2, 2 minus 1 is 1. 1 squared is 1. 1 times 3/2 is 3/2. Plus 1/2 is going to give me 4/2, or 2. If I plug in 0, 0 minus 1 is going to be -1. -1 squared is +1 times 3/2. It's going to be 3/2 plus 1/2 is 4/2, or 2. And then I plug in -1. -1 minus 1 is -2. -2 squared is +4. Then 4 times 3/2, we said 4 is the same as 4 over 1. So I multiply the 4 times the 3, I get 12. 1 times the 2, I get 2. So 12 over 2 plus 1 over 2 is 13 over 2. Or if I write that as a mixed number, 6.5, or 6.5 if I want to put it as a decimal. Now I plot each of these points. So 3, 6.5 over 3 on the x-axis, up 6.5 on the y-axis, put a point. 2, 2 over 2 on the x-axis, up 2 on the y-axis, put a point. 1, 1.5 over 1 on the x-axis, up 1/2 on the y-axis, put my vertex. 0, 2 over 0 on the x-axis, up 2 on the y-axis, put a point. And then -1, 6.5 over -1 on the x-axis, up 6.5 on the y-axis, put a point. Draw a parabola going through those. Sweet, we did it. Now, transformations to the parent function. So first, our a value is positive, sweet. But our a value is not 1. It's greater than 1, actually, right? 3 over 2 is the same as 1.5, or 1.5. So that's bigger than 1. Because this is bigger than 1, it's actually going to stretch your parent function. So this is going to be a vertical stretch by a factor of 3/2. We then look at our h. What did our h do? Well, our h is 1. So it's going to shift the parent function to the right 1 unit. So it's a horizontal translation, right 1 unit. And then our k is 1/2. So since our k is 1/2, that's going to be shifting the graph, the parent function, up 1/2 unit. So it's going to be a vertical translation up 1/2 unit. And you can see, if we had our parent function at 0, 0, where it normally is, what we do is we shift it to the right 1 unit, up 1/2 unit, and then stretch it up by a factor of 3/2. And that's how you get our function right here.
Have I told you how excited I am about my new box company? I can hardly contain it. Oh, you try.
Okay, doing the same thing. So first, we need to find our axis symmetry, or x value of the vertex, using x equals h. So what's our a, h, and k? Well, our a is 1/4. Our h is the opposite of what you see in here, so that's going to be +4. And our k is going to be exactly what you see out here. That's -5. We then figure out what's our axis symmetry. Well, it's x equals h, which in this case is x equals 4. So we go over to our graph at x equals 4. We put a vertical line. That's our axis symmetry. That should cut our parabola in half. Good way to check our work. We then make a t-table and put our vertex in the middle. So what's our vertex? H, k, 4, -5. So we put that in the middle of our t-table. We then pick 2 x values above 4 and 2 x values below 4, and then we are going to plug them into this particular function to get the y values that go with them. So let's do that. Here, when I plug these in, again, I have to do the parentheses first, then square it, then multiply it by 1/4, then subtract the 5. That's order of operations. So let's do that. 6, if I plug in 6 for x, 6 minus 4 is 2. 2 squared is 4. 4 times a 4th, 4 and the 4 just cancel each other out. You get 1. And then 1 minus 5 gives you -4. If I plug in 5 for x, so 5 minus 4 is going to be 1. 1 squared is 1. Times a 4th is a 4th. Minus 5, so 1/4 minus 5 is going to be -4 and 3/4. 3, if I plug in 3 for x, 3 minus 4 is going to give me -1. -1 squared is +1, times a 4th is a 4th. And then a 4th minus 5, we said, is -4 and 3/4. And then if I plug in 2, 2 minus 4 is -2. -2 squared is +4. Then you multiply that to 1/4. 4 times a 4th, the 4's just cancel each other out. You get 1. So 1 minus 5 then is -4. I have my points, so now all I have to do is plot those points. So let's plot them. 6, -4 over 6 on the x-axis, down -4 on the y-axis, put a point. 5, -4 and 3/4 over 5 on the x-axis, down -4 and 3/4, so almost to -5, we put a point. 4, -5 over 4 on the x-axis, down -5 on the y-axis, put a point. 3, -4 and 3/4 over 3 on the x-axis, down -4 and 3/4, so very close to -5 on the y-axis, put a point. And then 2, -4 over 2 on the x-axis, down -4 on the y-axis, put a point. Draw a parabola going through those. Sweet. We need to figure out what are our transformations to the parent function. So what did our a do, what did our h do, and what did our k do? So our a is positive, so it didn't reflect, but it's 1/4, which means that it's less than 1. Because your a value is between -1 and 1, we know that it's going to compress your parent function. That's why it's flatter than your parabola usually is. So this is going to be a vertical compression by a factor of 1/4, because that's our a value. We then see that our h is 4, which means it took the parent function and shifted it to the right 4 units. So it's a horizontal translation right 4 units. And then your k value is -5, so it shifted the graph down 5 units. So it's a vertical translation down 5 units. So that is how we got from our parent function, y equals x squared, to this function right here, our y equals 1/4 x minus 4 squared minus 5.